Hello everyone, it's Ananya Tiwari from Electronics and Computer Engineering.
Hello, I'm Sanchit from Electronics and Communication Engineering.
Hi everyone, I am Kanav Kapoor from Electronics and Communication Engineering.
Hello everyone, I am Varun Khurana from Electronics and Communication Engineering.
Hi everyone, I am Raj Yadav from Electronics and Computer Engineering.
So now that we're done with introduction, and yes, you can see the topic of our capstone is cloud sentiment detection using facial recognition. And having given the opportunity, we would like to shed some more light on the given topic. Basically, before starting the development of the project, a significant amount of research was carried out, as a result of which we decided to use a method that takes into account both local and global information. In our model, we took into consideration the bottom up approach, which is a system design approach where parts of the system are defined in details. Once these parts are designed and developed, then these parts or components are linked together to prepare a bigger component. This approach is repeated until a complete system is built. So in our system, it works by detecting and extracting the faces present in the image one by one individually, and then passes them out as input to an assemble of pre-training deep CNNs. So this model consists of various steps, which are face detection, face pre-processing, and individual face emotion CNN forward pass, a detail of which will be explained by Sanchit Kanwar.
Thank you, Ananya. So now let's talk about the backbone of our model. The dataset, quite simply, is a collection of data pieces that can be treated by a computer as a single unit for analytical and prediction purposes. So the dataset we are using here is FER 2013, which consists of three columns, namely emotion, pixels, and purpose. Pixel values are in the range of 0 to 225. The dataset consists of 35,887 grayscale images of size 48 into 48 classified into 7 emotions. To compare with this dataset, the raw data we obtain from the feed is pre-processed by cropping, scaling, and normalization. So it can easily be compared with the dataset available. Now coming to the algorithm, first we use the Haar cascade method to detect the faces in each frame of the webcam feed. Then the region of image containing the face is resized to the 48 into 48 size and passed to the input of the CNN. This is done as our original dataset consists of the same size of images. The number outputs a list of SOFTMAX scores for the 7 classes of emotions. The emotion with maximum score is displayed on the screen. That is our result. Now, Kanav would explain the further working of the model.
Thank you, Sanchit. So in our work plan, firstly, faces are detected using hard feature-based classifier. If the face is undetected, the system camera again tries to detect the face of the person. The detected face are stored as an array of feature columns. The extracted image is then processed to the deep neural network, that is in this case a convolution neural network, that is CNN. The CNN model, with the help of its hidden layer, normalizes the image acquired and reduce the image dimensionality using the optimizer as ReReLU function and matrix as accuracy. The image is processed in variable batch size with n number of approaches for train. After dimensional reduction, the image is passed to the output layer with optimizer as Adam, matrix as accuracy, and activation function as softmax. Once this process is complete, the model then understands the facial features and predicts the mood as per the understanding of the training data in the case of mood prediction. All the process take only second to execute at the initialization after it takes fraction of seconds to work. CNN forward pass. Convolution layer are the core building blocks of CNN. They consist of various independent learnable filters, also referred to as kernels, which have a very small perspective field but covers the full depth of the input volume. Our CNN accepts 48 cross 48 cross 3 array of pixel values. Pooling layer. So maximum pooling, which is one of the most used nonlinear pooling function, has been adopted in our CNN. It takes a 2 into cross 2 filter with a stride of 2 and applies it to very depth slice in the input. And for each subregion, output the maximum number. Now I will hand over to Varun for further explanation.
Thank you, Kanav. Now moving to the softmax classifier. So softmax classifier returns a categorical probability distribution, that is the probabilities of each class in the range is 0 to 1. Since this is a multi-class classification problem, that is we need to classify an input image as having one of the three emotion classes, positive, neutral, or negative. The sum of the probabilities of all the classes will be equal to 1, and the predicted emotion class will be the one with the highest probability. Coming to the convolutional 2D. The 2D convolution is fairly simple operation. At heart, you start with a kernel, which is simply a small matrix of weights. This kernel slides over the 2D input data, performing an element-wise multiplication with the part of the input it as currently on, and then summing up the results into a single output pixel. Coming to the optimizer and the loss function matrices. So ADAM is an adaptive learning rate method, meaning that it computes individual learning rates for different parameters using estimation of first and second movements of the gradients. Loss function simply measures the absolute difference between our prediction and the actual value. For this project, basically a softmax activation plus a cross entropy loss allow us to train our CNN to output a probability over the three emotion classes for each image. Coming to the validation, so validation is the final phase. Here we use keras. A metric is a function that is used to judge the performance of your model. A rectangle is drawn around the facial regions and the output is formatted above the rectangular box. Now I would like to hand over to Raj for further explanation.
Hello everyone, I'm Raj Yadav and I'll be demonstrating the working of our model. We got fairly accurate results from our model. Our model was able to detect the 7 classes of emotion accurately, and on the next slide, we'll see that the emotion on which our most focus was, that was the angry emotion. It was able to detect it accurately on my teammate Kanav and also on me. So this was just a snapshot of our project. Now I'll be demonstrating the live working of our project, for which I'll take a moment to share my screen and run the code. This was our project. This is the project folder, and from the terminal, now I'll give the command to run our main file. We can see that it is detecting the neutral emotion quite accurately. So I'll begin to change my emotions and see if it follows the follow suit. As we can see, it is following suit. So that was the demonstration of our project. Thank you for your patience. I'll be ending the PPT now. Thank you.